Continuing on in section 1.7, we can simplify algebraic expressions by combining the parts of the expression that are alike. A term is a number, variable, or product of numbers and variables. A constant is a term that has no variable. A coefficient is a numerical factor of a term. So terms, again, are things like 2, 4x, 3y, minus 6. So each of these is a term. Constants are terms that have no variables. So the constants here are like 2 and negative 6. They have no variables. They're always 2, always 6. There's no changing them. And the coefficient is the number part of a variable term. It's the 4 and the 3, what they're being multiplied by, what our variables are being multiplied by. Like terms have the exact same variable factors. To identify like terms, we compare the variable factors of the terms, like on the bottom of page 48. So our variables have to be exactly the same variable, same exponent. An algebraic expression is in simplest form if there are no more grouping symbols and all like terms have been combined. In example 5, we're going to combine like terms. So the first thing we need to do before we can simplify is figure out whether or not these are like terms and whether or not we can put them together. Well, here I have 6 times x squared plus 2 times x squared. So the x squareds are the same in both. They're exactly the same variable, same exponent. So because they're both x squareds, I'm going to combine them and keep it as an x squared term. So I've used my variable part. I know they're going to be x squareds. And now I can take my 6 plus my 2 and get 8. Think about your x squareds here kind of like a label. It's like 6 of something plus 2 of the exact same thing. Means we have 8 of those things. In B, I can combine my x terms. 5x, and remember this is like plus negative 3 or minus 3. And because our variables are just x's, we can combine those. And again, I know it's going to be an x, so I'm going to keep my x part. I'm going to take 5 minus 3 and get 2, or plus negative 3 and get 2. Here I also have another set, my negative 3 and my 4. Both of those have no variables at all. They're both constant terms. Constants can be added together as well because they have the exact same variable in that they don't have one. So negative 3 plus 4 gives me a positive 1. Last thing here is I look for anything that's left. I have a 6y and nothing I can combine it with. So here, I'm just going to put plus 6y. I can't combine it at all with anything else. Again, we can only add up things if they're the same. Think about it as like apples and oranges. I used to have 5 apples, then I had 3 less, now I have 2 apples. But oranges, I still have 6. We haven't changed those at all. Feel free to pause here and give these a try if you'd like. What's the simplest form of each expression here? Remember that our coefficient, if we don't have one, is a 1. So in front of my y is a 1 there. And these are like terms because they have the exact same variable, the y. So I'm going to label them as a y, and then I don't have to worry about my variable anymore. I keep my variable exactly the way it's written. And now I have 3 minus 1, which is 2. Let's check in B and see if our variables are exactly the same. Here I have m to the first power, n to the fourth power. And they are exactly the same. So I'm going to keep that variable exactly as how it was written. And now I don't worry about it anymore. I know both of these things that I'm combining are m(n) to the fourths. So I have my labeled part there, my variable part. And I can take negative 7 minus 5, which is going to give me negative 12. Remember, when we subtract, we change to adding the opposite. So negative 7 plus negative 5, I have the same signs. I'm going to find the sum and add the absolute values. 7 plus 5 gives me 12. And I look back at my signs, negative. So negative 12 times m(n) to the fourth power. If we look at C here, though, things get a little bit crazier. When I go to compare like terms, I have y cubed here. Here I have just one y. That's not the same. And y cubed here. Now we check our second variable, a z and a z. So these two terms, my first term and my last term, can be added together. And they stay just y cubed z. That's different than yz cubed, and I'll show you how here in just a second. Remember, our coefficient is a 1 if there isn't one listed. We've used our variables already, so now all I have left are my number parts. 7 plus 1 gives me 8. Now I still have one more term. I can't add it to anything, so I'm just going to bring it down just as it's written. So here, y cubed z is the same as saying y times itself, exponent number of times, and then z. And that's different than if I had y z times itself, exponent number of times. So if you look at them at first glance, they both have a y, they both have a z, they both have a cubed, but they mean very different things. Y cubed z versus z cubed y give us very different results for our variables. So we have to be careful there. They have to be the exact same variables in the exact same exponents for each variable before we can combine them. Quick recap here for this section. The distributive property can be used to simplify the product of a number and a sum or difference. And an algebraic expression can be simplified by combining the parts of the expression that are alike. And that's all I have for section 1.7.